The theorem that we are going to talk about, the Pythagoras theorem, is actually deduced from this theorem that we are looking at. The theorem reads as follows. The theorem reads as follows. Let me quickly do this so that we can have a clear understanding of what I'm talking about. Let's forget the top part there. This is the theorem in question. This is the theorem in question. It says the perpendicular line drawn from the vertex of the right angle of right-angled triangle to the hypotenuse divides the triangle into two triangles that are similar to each other and are similar to the triangle. In essence, what we are given here is this. We are given a right-angled triangle. Let me put away this so that we can have our nice right-angled triangle. The story is about a right-angled triangle. The story is about a right-angled triangle. Fine. Why do we say this is a right-angled triangle? Because this angle must always be equal to 90. If we are having triangle A, B, C, right-angled triangle, right-angled triangle A, B, C. The reason why we refer to that as right-angled triangle because one of its angles is 90. And what is interesting about this is that the side which is perpendicular to this must always be the longest side, which becomes the hypotenuse. The side which is opposite to this is side BC. Side BC is opposite to 90-degree angle, and this is the longest side, which is called the hypotenuse. Now, if we read the theorem, the theorem reads as follows. It says, the line drawn from the vertex of the right angle, from the corner, the vertex is the corner, from the corner of the right angle. So it means what is requested of us is to draw the line coming from the corner of the right angle, the vertex of the right angle. And this line must actually be perpendicular. It must be perpendicular to the hypotenuse. Remember, this is the hypotenuse. And every time when you say the line becomes perpendicular, when we say two lines become perpendicular, it means the magnitude of this must be the same. It means we're having right angles at that. Fine. So we are drawing the line. We are actually drawing the line. I'm trying to hide this so that we can have an understanding of what is going on. We are drawing the line. They say the line drawn, perpendicular drawn from the vertex. It means this line must be perpendicular, drawn from the vertex of the right angle, from the corner of the right angle. The vertex is the corner of the right angle, of a right angle triangle to the hypotenuse. This line must always be perpendicular to the hypotenuse BC. This line must divide the triangle into two triangles. We now have triangle, if I can have this as point D, it means we are having two triangles, ABD and triangle ADC. It divides triangle into two triangles that are similar to each other and similar to the original triangle. All in all, it means we are having three triangles here. We are having triangle, the bigger triangle, which is ABC, ABD, and ADC. We are having three triangles there. Right. The information given to us. All right. What is it that we are supposed to... we are already given the magnitude of these angles. Fine. What is it that we are requested to prove? We are requested to prove that triangle ABC is similar to triangle DBA, and that is also similar to triangle DAC. That is what is requested of us. Fine. Having said that, it means I can divide angle D, which is equals to 180, into D1 and D2. Let me do that. I'm having my D1 and my D2. Fine. What I'm requested to do, learners, is to prove that triangle A, the bigger triangle, is similar to DBA, that is this triangle, and similar to DAC. That is, the three triangles are similar. Fine. Now I must source out the information given to me. I must source out the information given to me. The information given to me was such that when this line was drawn, AD was drawn, line AD has divided A into A1 and A2, much as it has done that with what? With D, having divided D into D1 and D2. Fine. Now, if we want to talk about the information which is given to us, I think this is what we should have started. The given information to us is such that, much as we don't know the exact value of A1 and A2, what we know is that when you add A1 with A2, the magnitude of the angle there must be equals to 90, because we were given that A is 90. It's a right angle. Fine. And the other information that we can source out from this is when we add A1, which is this angle with that angle, they must give you 90. That is, it means the sum of A1 and A2 must also be equals to, that must also be equals to D2, because D2 is equals to 90. Because D2 is equals to 90. That is the information which is already provided to us. Now, let us carry on and try to solve this as a theorem. Let us carry on and try to solve this as a theorem.